Greetings. In the previous lectures 1, 2, 3, we have studied first 4 applications of derivatives. Let us continue with the application of derivatives and let's see the 5th application of derivative as increasing and decreasing function. First of all, we will define increasing function. A function f of x is said to be monotonically, or this word is also known as strictly increasing, if for any x1 x2 belongs to open interval ab such that x1 less than x2 implies f of x1 less than f of x2. So for a function f of x defined on closed interval ab, it is said to be monotonically increasing. It is said to be monotonically increasing or strictly increasing on interval ab if for any value. That means if you consider any values of x1 and x2 in the interval ab, x1 less than x2 should imply f of x1 less than f of x2. Hence, such function is said to be increasing function. In other words, जैसे आपका अगर x increase होता है तो f of x भी increase होना चाहिए. So, such is called as increasing function. In the aspect of derivative, we can have the result f of x is increasing if and only if f dash of x greater than 0 for every x. So earlier was the definition, this is the condition, that is the application of derivative in increasing function. F of x is increasing if and only if f dash of x greater than 0. f dash of x आपका greater than 0 होना चाहिए for every x. Then it is said to be increasing or strictly increasing function. If it is greater equal to 0, then it is increasing. But if it is strictly greater than 0, then we said to be monotonically or strictly increasing on the interval ab. Similarly, next definition is decreasing function. A function f of x is said to be monotonically decreasing on interval ab if for any x1 x2 belongs to ab with x1 less than x2 implies f of x1 greater than f of x2. मतलब आपका x increase होते जाएगा, at that time f of x is decreasing. So such type of function is said to be decreasing function. Hence, in the application of derivative, correction over here, decreasing चाहिए. F of x is decreasing if and only if f dash of x less than 0 for every x. So these two lines are very important for us while solving the problems of increasing and decreasing function. We are interested in the values of x where f dash of x greater than 0, hence function is increasing, or vice versa, increasing है तो f dash of x greater than 0. Similarly, decreasing if f dash of x less than 0. A very important remark, if f dash of x equal to 0, we cannot predict whether f of x equal to is increasing or decreasing at that point. That means our test fails. If f dash of x positive, increasing, negative, decreasing. But if it is equal to 0, we cannot predict anything. So, such point is also called as a saddle point. Such point is also known as saddle point, that we don't know anything if f dash of x equal to 0. Let us solve few examples on increasing and decreasing function. Test whether f of x equal to 2 minus 3x plus 3x square minus x cube is increasing or decreasing. So first, whenever there is a problem of increasing or decreasing function and we have to test either it is increasing or decreasing, so we will calculate f dash of x. So differentiating f of x with respect to x, therefore f dash of x will be minus 3x plus 6x minus 3x square. Taking minus 3 common, in bracket you will get x square minus 2x plus 1, and x square minus 2x plus 1 can be written as x minus 1 bracket square. So for any value of x belongs to R, x minus 1 bracket square will be greater equal 0, क्योंकि ब्रैकेट स्क्वायर है तो वो पॉजिटिव ही रहने वाला है, एंड फॉर x इक्वल टू 1 इट इज इक्वल टू 0. सो ये माइनस 3 एज इट इज रहेगा. दिस इज नेगेटिव नंबर, दिस इज पॉजिटिव नंबर, सो ऑब्वियसली द प्रोडक्ट विल बी नेगेटिव, और x इक्वल टू 1 के लिए 0 है. देयरफॉर f dash of x less equal 0 for every x belongs to R. Hence, using the earlier result, f of x is decreasing function. So, if f dash of x less than 0 आता तो strictly और monotonically decreasing आता. यहाँ पे equal to का भी possibility है, so it is decreasing function. Okay, so whenever we want to check whether it is increasing or decreasing, we will find out f dash of x, and then we try to express it in terms of either whether it is positive or negative for every values of x. Next example. Find the values of f of x equal to 2x cube minus 3x square. Find the values of x, यहाँ पे correction है, find the values of x where f of x equal to 2x cube minus 3x square minus 12x plus 6 is strictly increasing. So whenever function is increasing, we have f dash of x positive. If f dash x positive, it is increasing, vice versa. So using the same definition, so f of x differentiate करेंगे f dash of x. So whenever we want to find the value of f of x, find the value of x where function is either increasing or decreasing, we will factorize it into linear factors और some two terms के product में लेना है. So taking x 6 common, we get x square minus x minus 2. So x square minus x minus 2 का factorization आएगा x minus 2 x plus 1. So f dash of x equal to 6 into x minus 2 into x plus 1. As f of x is strictly increasing, therefore f dash of x greater than 0, strictly greater than 0. So f dash of x की value put करेंगे तो 6 into x minus 2 into x plus 1 greater than 0. 6 से divide होगा तो आपका मिलेगा x minus 2 into x plus 1 greater than 0. So in the left hand side we have two terms, product of two terms which is positive. So either both term must be positive or both term must be negative. Hence x minus 2 greater than 0 and x plus 1 greater than 0, or x minus 2 less than 0, x plus 1 less than 0. That is x greater than 2 and x greater than minus 1, or x less than 2, x less than minus 1. So if you observe the first one, so what you will do, draw a real line, एक minus 1 point ले लो, 2 point ले लो. So x greater than 2. So x greater than 2 means the values of x which are to the right hand of 2, and x greater than 1 minus 1, the values of x which are to the right of minus 1. So common portion for this will be x greater than 2, and for this one x less than 2 means to the left hand of 2, and less than minus 1 means to the left hand of minus 1. So the common values will be x less than minus 1. So we get x greater than 2 or x less than minus 1. In the form of interval, x greater than 2 means x belongs to open interval to infinity. Less than minus 1 means minus infinity to minus 1. और का मतलब union. Therefore, x belongs to open interval minus infinity to minus 1 union to infinity, where f of x is strictly increasing. So whenever we want to find the values of x, whether the function is increasing or decreasing, we will differentiate f of x. We will write down f dash of x in the product of two terms, and taking, whether it is positive or negative depending on increasing or decreasing, we will find the values of x. Let's solve one example of decreasing. Find the values of f of x equal to 2x cube minus 3x square minus 12x plus 6 is strictly decreasing. Same function we are checking for decreasing. So f of x equal to this, f dash of x 6x square minus 6x minus 12. So 6 into x square minus x minus 2. So 6 into x minus 2 into x plus 1. As we have studied in example number 15, same example for decreasing we are checking. As f of x is strictly decreasing, therefore f dash of x less than 0. Therefore 6 into x minus 2 into x plus 1 less than 0. 6 से divide करते हैं, 6 is a positive number, so dividing that. So we get two numbers, product of two numbers negative है. So either one of them is negative. So x minus 2 greater than 0 and x plus 1 less than 0, or x minus 2 less than 0 and x plus 1 greater than 0. That may be the possibility. Therefore x greater than 2 and x less than minus 1, or x less than 2, x greater than minus 1. So x greater than minus 1 and x less than 2 matlab minus 1 less than x less than 2. This will be minus 1 less than x less than 2. But if you observe, for the first one, x greater than 2 and x less than minus 1, so there is nothing common in this, so this is invalid. Therefore x greater than 2 and x less than minus 1 is not possible. So only possibility here will be minus 1 less than x less than 2. Therefore x belongs to open interval minus 1 2, where f of x is strictly decreasing. If you observe this step, if there is no common value of x which satisfies both the conditions, hence it is not possible. And here it can be rewritten as minus 1 less than x, x less than 2. Therefore combining this we get minus 1 less than x less than 2. Let's solve the last example of this time. Show that f of x equal to x minus cos x is increasing for all x. That means we have to show f dash of x is greater than 0. So f of x is equal to x minus cos x, differentiating we get derivative of x is 1 minus derivative of cos x minus sin x, minus minus plus 1 plus sin x. Now 1 can be written as sin square x by 2 plus cos square x by 2, and sin x can be written as 2 sin x by 2 into cos x by 2. If you observe, this is nothing but sin x by 2 plus cos x by 2 bracket square. So sin x by 2 plus cos x by 2 bracket square. So obviously for any value of x, this is bracket square, hence it is positive. Therefore f dash of x greater than 0 for all x. That means f of x is increasing for all x. So this is it from increasing and decreasing function. Thank you very much.